All right, so 2.5 notes today. Lesson 5 is about absolute value functions and graphs. So that's what we're going to be talking about today. And our goal is to graph absolute value functions. You remember this? All right, so graphing absolute value functions, we have 3 different methods we can use. A general form for an absolute value function will look like this, okay? M's not allowed to be 0 because if M were to be 0, then this would just be a number in here because M is what's with X. So if M was 0, then your X term would go away and B would just be a number because B is a number, C is a number, and M is a number. And if you took the absolute value of a number and add another number to it, it would be y equals a number. And if I have y equals a number, like y equals 7, what does that graph look like? Okay, so yeah, you would graph it with the y-axis with 7 graphed on the y, but then it is considered a line. How would we draw the line in? A horizontal line. Yes, we would draw a horizontal line, so that would be how that would graph. That's not an absolute value function because in order for it to be an absolute value, it's either going to be a v that looks like this, or it's a upside down v that looks like this. It cannot be a sideways v because that's like an alligator mouth and the alligator ate you. So no sideways v's. Those are scary. You can draw little teeth in it and then it ate you and you didn't survive to get your grade. Okay, so no sideways v's. Okay, either has to be a v or it looks like a mountaintop, an upside down v. It will look like a v if our equation looks exactly something like this. Okay. In order for it to be upside down, there would have to be a negative sign in front of the absolute value bars. Or a negative number outside the absolute value bars. But you'll see where that is in just a little bit. Okay. Now, in order to find the vertex, to figure out where the vertex is located, what we're going to do is we're going to take the inside of the absolute value bars and we set it equal to 0. So in this case, if I want to find the vertex, I'm going to set mx plus b equal to 0. And then we want to know what our vertex is. Now the vertex is the point of the v. Whether it's the top or the bottom of that graph, it's the point of the v. Where that v comes together, it forms that point. Okay? Now, we have to figure out what that point is. So we're going to have to figure out the x-coordinate and we're going to have to figure out the y-coordinate. So once you set the inside equal to 0, if you solve for x, that'll tell you what the x-coordinate is. So in this case, we would subtract b, and then we would divide by m. Okay, so we'll have that number, and that would go right here. Okay, now that's going to be a number eventually because all those are going to be numbers other than the x. And then what we'll do is we'll take that number and we plug it back into x and we figure out what f of x is, which is the same thing as our y. Okay, so when we find x, you're going to plug that in, then you're going to solve for y. So once you have your x, then you plug it in to find y. So that says plug in x. I don't know if you can see that very well. So that's kind of the big idea with absolute value. We have to always make sure we know how to find that vertex. So the first way that we're going to do this is from a table. When we do this from a table, we're going to have to start by finding the vertex. Okay, the steps are written over here on the left. We're going to do the example over here on the right. Make a table with the vertex at the center. So you're going to put the vertex in the center of the table every single time. But how do we find the vertex? What are we going to do? What are we going to do? What did we do first when we're trying to find the vertex? Set the inside and equal to 0. So what's the inside of this equation? Yes, the 3x plus 12 is going to be the inside. So we're taking 3x plus 12 and we set it equal to 0. And we're going to have to solve for x. Now we're going to put the vertex right here in the center of that table. So what's my first step here to get x alone? Subtract the 12. So we have 3x equals negative 12, and then what? Divide by 3 on both sides. And we're going to get x equals, that'll be a negative 4. What do I do now that I have negative 4? Now we'll have to plug in our x. So that is our x. So we're going to put in negative 4 for our x. Okay? Now, when we plug in negative 4, we're going to have to figure out what the y value is. So let me just kind of write this out. You don't have to always show all of this work, but I'm going to show this work so we can see it. Actually, before I cover this up. Since negative 4 is the middle, when I count down from negative 4, what's the number below negative 4? Negative 5 is below negative 4. Negative 6 is below that. Okay, and then come in the other direction. So that when you're going down, you're counting up. Negative 6, negative 5, negative 4. What comes next? Negative 3, and then negative 2. So those are the numbers that we're going to have to plug into this equation to find all of those y values, just like we would in a table, which we practice with linear functions. Except for now we're plugging them into an absolute value function. So y equals, the first number that we're plugging in is negative 6. So 3 times negative 6 plus 12. When you are trying to find y is already alone. So we're just simplifying. We're going to use PEMDAS to simplify this right side. First, you're going to have to do the multiplication. You're going to treat these like parentheses. You have to simplify it to one number first and then take the absolute value of it. So we have the absolute value. That's going to be negative 18 plus 12. What's negative 18 plus 12? Negative 6. And what is the absolute value of negative 6? How far away is negative 6 from 0? So we're going to have y equals 6 for our final answer. So then once we have y is 6, we plugged in negative 6 and we got y is 6. Okay, let's try it with negative 5. Y equals 3 times negative 5 plus 12. 3 times negative 5 is negative 15 plus 12. What's negative 15 plus 12? Negative 3. And what is the absolute value of negative 3? How far away is 3, or how far away is negative 3 from 0 on a number line? So y equals 3. So we're going to plug in 3 there. Okay, now we're going to do it where we're going to plug in negative 4. Y equals 3 times negative 4 plus 12. 3 times negative 4 is going to be negative 12 plus 12. Which is 0. And how far away is 0 from 0 on the number line? So y equals 0. So I'm going to put that in there. Now I'm going to plug in negative 3. Y equals the absolute value, that'll be negative 9 plus 12. Negative 9 and 12 is 3. How far away is 3 from 0 on the number line? No, it's positive. It is positive. Notice that on both sides of 0, you have 3. What do you think the y value at -2 is going to be? 6. It is a mirror image around that vertex. So you should be able to see that mirror image around that vertex. Always check it though, okay? You don't only want to do half and then assume this to be true, because that's how you're going to find your error if you found your vertex incorrectly. If it's not mirrored, then your vertex is probably not right, okay? So then you'll have to go back and fix your vertex. So then now that we have this, we'll just plot it. So we're going to put some scales on here. So there's 2, 4, 6, 8, -2, -4, -6, -8, 2, 4, 6, 8, -2, 4, -6, -8. All right, now that I have scales on my graph, I'm going to plot these points. -6, 6 goes to the left 6, up 6, and that's a point. Dx, this is your x-axis, this is your y-axis. So you go to -6 on the x, +6 on the y, that's where your point is. The next point is -5, 3. So -5 on the x, 3 on the y is right there. -4, 0 is to the left 4. You don't go up or down 0 at all. -3, 3. Go to -3 into +3. There you are. And -2 is at 6. From there, you should be able to see a pattern and be able to add more points until it's off the graph. So it's going up 3, out 1, up 3, out 1, up 3, out 1. I'm going to add another point on each side, and then I will connect it with my straight edge, because it's important that I have a nice accurate graph, and you'll need a straight edge for that. This is a nice V. Questions on this one? No? Okay. This is going to be the most common way. I would say you're going to probably use this 9 out of 10 times. Yeah, probably that often. The next one is to write 2 linear equations. This is pretty difficult. We will do this, but it is difficult. Okay? So get the absolute value bars alone. That's step 1. Are the absolute value bars alone? No. What's going on the outside of them? It's adding 3. So what we're going to have to do is we're going to have to subtract 3 from both sides. Y minus 3, those are not like terms, so I'm going to have to write it as y minus 3. Now the absolute value bars are alone. Okay, so the absolute value bar is alone. That's done. Step 2 says to break the absolute value equation into 2 equations. So I always imagine that these brackets are breaking down and become arrows to break it off into the 2 scenarios. That was so much work to break down those brick walls that the right side is going to say 2x minus 4 on both of the equations, on both scenarios. But the left side, one of them remains the same, y minus 3. The other becomes the opposite, negative y plus 3. Remember, when you're making it the opposite, you have to negate both terms. Okay? Then we have to solve for y, because I don't know how to graph this as an equation. But if I get y alone and add 3 on both sides, I do know how to graph y equals 2x minus 1, or subtract 3 on both sides. I'll get negative y equals 2x minus 7. Then you're going to have to divide by negative 1 on everything to get y equals negative 2x plus 7, which I also know how to graph that linear equation. Now that I have those two equations, what I can do is I'm going to plot all the points. Where do I start if I have y equals 2x minus 1? Negative 1 on the which axis? On the y-axis, which is this one that goes up or down. So I'm going to go to negative 1. Let's just make these scales 1, and then I should still put scales on it, though. Okay, so I'm starting at negative 1 on the y-axis, and then my slope is technically 2 over 1, so how do I move for that slope? Up 2 to the right 1. Up 2 to the right 1. And we're going to do that until we've run out of graph, and then when you can't go anymore, then you're going to go back to your original point, and you're going to go in the opposite direction. So when we go to graph the other one is 7 on the y-axis. So here. And it has a negative 2 slope, so it's going down 2 to the right 1. So I am going to keep going until I run out of graph. And now this looks a little messy. Well, can you see it kind of makes an X? Okay. Is an absolute value function an X on your graph? It's a V, right? It has to be an upward facing V or a downward facing V. So a V or a mountaintop. How do we tell the difference if it is a V versus a mountaintop? What was the difference in the equations if it was a V versus if it was a mountaintop? There was a negative sign in front of the absolute value bars. Okay? So from here, we have to look and say, was there a negative sign in front of the absolute value bars? So it's not the mountaintop. It means it has to be the V. Since it has to be the V, what we can do then is we can connect. Here's where the X crosses at that point right there. So that's your vertex. And what we're going to do is we're going to connect the top of the X because this is the actual graph. All those bottom points don't even matter. Okay? You can leave them there, but just connect the top half. Does that make sense? So you don't have to erase these, just connect the actual points. All right. From a graphing calculator. Okay, I can show you on a graphing calculator, but many of you don't have them. So instead, I've told you a number of times that there are 2 calculators you can get on your phone. One of them was Calculate 84. If you don't already have that, that's okay. You can instead use Desmos. So let me show you. You're going to go to desmos.com. So everyone grab out your phone right now so you can see this. desmos.com. That's not what I wanted though. Oh, desmos.com/calculator, sorry. If you start typing in Desmos space graphing calculator, I think it's like one of those first ones on there. But it's desmos.com/calculator. And then you're at this screen here. Like this. All right, so once we get in there, what we're going to do is we are going to type this in exactly how it looks. We are going to type a y, which is right there on your screen. It's right up here where next to the x, y. We're going to type an equal sign, equals. All right, so functions, I think is where it is. Maybe not. To remember. Oops. Where'd I go? Oh, never mind. Just kidding. You do not have to go to functions. Look at right here underneath the parentheses. See how it says the absolute value of A? Yeah. If you click on that, it should bring up your absolute value bars, and then you're typing on the inside, x minus 2, and on the outside, you're going to write plus 3. And then what you can do is we can actually look at this graph. And if you click on a point, it shows you that that vertex is at 2, 3. So we're going to put that vertex at 2, 3. So on our graph here, put some scales. Right 2 up 3. And you could put another point at 0, 5. And from there, you can see that it'll have a mirror image point at 4, then 5. So that's 2 away from the vertex. So 2 away from the vertex, you're also at that same height. You see what I'm doing? And you can actually click on this and slide, and it will show you 4 is at 5. If you go to 5, 5 is at 6. So you're just going up 1, out 1. So I'm going to put in all those points. You can tell that right from this graph. This way, 1, if you want to slide on that one, 1 is at 4. And so you're going up 1, out 1 that direction. Because it's a mirror image, you're always going up 1, out the same number. Or up however many, out 1. However you want to say it. Okay. And then what we're going to do is we're going to connect all these points. And we've used a graphing calculator. Now, if you would like to use Calculate 84, because let's say you downloaded Calculate 84 and have that on your phone. It looks like this, Calculate 84. I'm going to hit skip for now. Skip anyways. If you have an iPhone, Calculate 84 is available. If you have an Android, then you can use, what is it called? It's an emulator. It's a graphing calculator emulator. Wabbit. It's called Wabbit. You can use Wabbit. And Wabbit, you can get it's the emulator for a TI-84, which is exactly, looks like this, okay? So if you then go to y equals, you would type in your equation, okay? Your y equals is already there. So you need to fill in the absolute value bars, but to get that, you have to go to math, over to number, and then it's number 1, absolute value. So now your absolute value bars are there, and you type in x, which is next to alpha, minus 2, right arrow over to the outside, plus 3. Then when you hit graph, just like before, it shows you the actual graph. You can click right on the graph to find those points. Or if you hit trace, you can actually type in where is 0 at and hit enter. It will tell you 0 is at 5. Type in 1, hit enter, it tells you it's at 4. 2, hit enter, it tells you that it's at 3. So you can then find all your points that way. It's a little bit easier to just type them in versus trying to slide your finger on Desmos. So either of those are options for graphing calculators that you guys all have access to on your phones. So that's it for notes. The next page in your packet is your assignment. The first set of problems tell you to write 2 linear equations. So you're going to have to show your work write out the two linear equations, plot all those points, and then remember, only connect either the top B or the mountaintop based on if there's a negative sign in front of the absolute value bars. And is that negative sign in front of the absolute value bars? No, it's on the inside of them, so that one would not count. On 7 through 10, it says to make a table for each function. So do your work, find your vertex, put it in the middle of your table. And 11 through 14, it's just matching. So you could use a graphing calculator and type in this equation and figure out which graph does it look like. Does that make sense? So you should have plenty of time to get this done before the end of class.